This is part 2 of our reasons notes. And these notes are for when you're using angles. So remember, reasons are postulates, which are things that we assume or agree to be true. They are theorems, which are things that we prove to be true. Or they are definitions, which is just how we describe different different parts of geometry. So let's start with the angle addition postulate. So this is something that we assume to be true. If point B lies in the interior, so if I've got B in the middle here, maybe we'll, I don't know. I don't want it to look like it's in the, I don't want it to look like it splits it in half. It's just somewhere in between in the interior of this angle. So this angle is angle AD. C. ADC, B is in the middle. Then we say that the measure of ADB, so I need to draw a line here. Let's see if I can get my line tool. The measure of angle ADB plus the measure of angle BDC is equal to the measure of angle ADC, which makes sense. Those two little angles equal the big angle. And again, postulates should generally make sense, right? To us. Okay. So that's angle addition. That's I guess part 1. Because we also have angle addition part 2. Now, angle addition part 2 says if AOC is a straight angle. Now, a straight angle it's really just a line, right? This is a straight angle right here. And so I've got A here, and I've got O here, and C here. If AOC is a straight angle, and B is any point not on AC, then AOB plus MOC, the measure of angle AOB plus the measure of angle BOC equals 180. So let me put B somewhere, I don't know, over here. And again, we'll use the line tool to draw a line from O to B. So what this postulate is saying that if I've got a straight angle and B is any point not on AC, then these two angles add to 180 degrees. Okay, now I feel like we're missing maybe a little part. A straight angle is 180 degrees. Maybe that should be a definition, right? If an angle is 180 degrees, then it's a straight angle. If there is a straight angle, then it's 100 degrees. So that's something that you'll never have to actually define, which is why we don't include it as a reason. That's something that we are saying is true, that straight angles are 180 degrees. So since straight angles are 180 degrees, then those angles that make up a straight angle add to 180 degrees. So that's angle addition part 2. This might not be a postulate. This might be more of a theorem, but it really is just part 2 of angle addition. It's an extension of the angle addition postulate. Maybe it's a specific case of angle addition. So anyways, that's angle addition part 2. The definition of an angle bisector. Okay, so we have OC bisecting AOB. All right, so let's go ahead and draw. Let's go ahead and draw A, O, B, and then we have OC, so here's C, and it's OC, really, I would say should be a ray. Ray OC. Ray OC. And this probably won't look like it actually splits it in half, but it's not too bad. Okay, so OC, this ray bisects AOB. if and only if those two angles are congruent. Okay, so if OC bisects AOB, then those AOC, so this angle right here, this angle right here is congruent to this angle right here. AOC is congruent to COB. Should be a little more curved. It's not really going super well for me. Okay. There we go. AOC is congruent to COB. And that's the definition of an angle bisector. And if I know that those two angles are congruent, then I know that OC bisects AOB. Hopefully that makes sense. Okay, congruent angles. This is another conversion where we're going, it's a conversion, moving from, oh my gosh, conversion. My head is not in the game right now. Conversion, so we're going from the shape, the size and shape of an angle to the measurement of an angle. So if I know that two angles, R and S, are congruent, then they have the same measure. And again, when we're using things like this right here, this definition of an angle bisector, I'm only saying that the angles are congruent. I'm not saying anything about their measures. So if you wanted to say something about their measures, you would need to use the definition of congruent angles. Okay? The definition of right angles, if angle 1's a right angle, then the measure of angle 1 is 90 degrees. So here we're saying angle 1, this is angle 1. If it's a right angle, then it's 90 degrees. If an angle is 90 degrees, then it's a right angle. It's pretty basic. It's something that you've seen before. This little like square, half of a square looking thing, that shows us that the angle is right. That's how we denote that there is a right angle. It's by kind of making a square in the angle. Okay, so this is the last part, and for now I'm just going to talk about it. In another video, I'll prove it. Okay, so the angle bisector theorem, if BX is the bisector of angle ABC, so we have here angle, here's A, here's B, here's C, and we have ray BX, and it's called the bisector. Then the measure of angle ABX is half the measure of ABC, and the measure of angle XBC is half the measure of angle ABC. So that's the angle bisector theorem. And remember, theorems are things that we prove. So I would even challenge you, before you maybe go looking for the next video, see if you could prove this, because you can prove it given some basic algebraic reasons that we've talked about in the past, and everything on this page. But that's it for this video. I hope that you have a better grasp of the reasons that we use to prove things concerning angles.